Hello, welcome to the Mayhem Lab. In this episode, Kevin and I are going to talk about the creation of the hardware hacking village
for CypherCon 5.0.
5.0.
Yeah, so we've done hardware projects at CypherCon since CypherCon 2, right?
Yeah, I think so.
CypherCon 2, we had a Morse code board that people soldered together. CypherCon 3 was the handheld video game.
The arcade game, yep.
CypherCon 4 was a little puzzle board.
Yes.
We touched things on. We did that one at ThoughtCon as well.
The dead guy.
And so, yeah, we struggled a little bit coming up with idea for this year. Last year, the project board, we actually had pre-assembled them here in Michael's basement.
Yeah.
And learned that we should never, ever do that again. We're a bit out of time to do like assembly overseas, and it's a little expensive, but mostly just a time suck. So I think we're going to go back to just solder something together. We don't want to take over. It's not the badge for the conference. We just want.
Right. Well, then I think people really enjoyed it. You get the hands-on experience. You get to, solder something maybe you haven't soldered things before, or you're sort of still a novice at soldering. I think it's a great way to throw some components on a board and have some pride. It's like, I made this thing.
Yep.
And they get to do stuff with it.
Yep. Make it do something cool.
Yeah.
So I thought this would be a good video for me to show Michael what I had come up with so far, because we talked a little bit, but I kind of ran with it from there.
Which is completely unusual.
We've normally used the Arduino boards or the Atmega boards at Tiny's or the Arduino boards. This year I wanted to try this STM32 board. I don't know, Michael, if you can switch it over to the camera. We'll see if that works here. So this is called a Blue Pill. It's got an STM32 processor on it. It runs at 72 megahertz, whereas like a normal Arduino runs, I think, at like 8 megahertz.
Okay.
So it's more powerful, or it's faster from that perspective. It's got more input and output pins, and it's cheaper. This board, you can get this from AliExpress for like $1.70.
Nice.
So it's one of the few kind of more powerful boards that's within our budget for handing these out at CypherCon.
Right. And I know we're going to get into this in a little bit, but worth noting, it comes with, or you can get it to come with the programmer, which we're going to use here in a little while. So you can get the programmer and the board for basically the same price as an Arduino.
Yep. Yeah, so it's pretty slick. This is the first project we've done with this. We were thinking, do we do something with a screen? Do we do something with I was playing a bit with like audio with like a speaker, but it's hard to get loudspeakers from a very small running off a battery or something. And again, we're short on time, so we also like when we can build a badge that runs off a battery. So like something that you can use the badge runs off a battery, so you can hang it on your neck.
Yeah, you don't have to be tethered to a computer.
Right,
That is an important thing.
But again, short on time, need something, keep it simple, stupid. So I kind of came up with this idea for let's run some kind of game on the serial port, just like a text-based game. So I don't know, Michael, if you can switch over to the computer. I sent you a link. So the Arduino, you program in a variant of C, actually C++. And so I was looking for text-based games, old text-based games that would run in C++. Zork is written in, I forget the language, but it's a text adventure type language, so I couldn't find a C version of Zork. I was also looking hard to try and find the original Oregon Trail. I thought that'd be cool to play Oregon Trail on the USB port, but I couldn't find that. But I did find Hunt The Wumpus. I'd seen Hunt The Wumpus when I built that simulated Altair computer that we had at Skunk's Misery. So it's kind of a well-known, very old text-based game. But in searching for the C code for it, I want to show you this website. It was pretty cool. It's Rosetta code. It takes a bunch of different programs and writes them in people write them in a variety of languages. So here you can see the same game written in
Nice.
all kinds of different languages. So that was kind of cool.
Yeah.
But it also has the C++ version, which
Which is what we need.
kind of gives us a starting point. So we could work off of that.
Nice. But now, if I remember correctly, you were saying that this is used to a screen, right? So this is our adaptation.
I think somebody had taken this, adapted it to, there's an Arduino version of Hunt the Wumpus out there, and they've got an LED screen.
Okay.
So, if you scroll down a little bit on here, up a little bit, you see they've got like IO stream. Instead of using IO stream, we're going to be using the standard serial functions that are built into Arduino: serial.print, serial.write, serial.read.
Right.
So we end up replacing a portion of the code, a lot of copy and paste to kind of change how the code works. But overall, it works pretty well.
Nice. And you've already done all that?
I took a first stab at it just as a proof of concept, and it was really buggy. So
you need me to fix it?
Yeah, pretty much.
I knew why Kevin stopped over.
But far enough to say, okay, yeah, that'll work. So one half of it, which is you can plug it in, play Hunt the Wumpus. So if somebody's at the con, they can just plug the board in and play with it. I think it can be done, which is as far as I got. It can be done.
Excellent.
And the other thing is, again, it's got to be a soldering project. So we want to solder this onto something.
Mm-hmm.
So if we switch back over to this camera, if I can tip it up a little bit, maybe. So we love these little WS2812B LED strips. We've used these on lots of projects before, including one of the CypherCon projects. They actually work pretty well to cut a strip of these, stick it down onto a PCB, and just have people solder the 3 points at the end onto the PCB. We did that with the CypherCon 3 game, and it worked out really well. Mm-hmm. So I thought we could do that again. But one of the tricks with these boards, the STM32, is the STM32 runs at 3.3 volts.
Yeah.
It's got a 5 volt output. So it's got 5 volt input from the USB. It's got 5 volt output on one of the pins, but its data out is all 3.3 volts.
So it's got a regulator on it. It's dropping it?
Yeah, it's dropping it down to 3.3 volts, and the chip itself runs at 3.3 volts.
Okay.
Now, a lot of times that's not a problem, because if you're trying to communicate between something that expects 5 volts and something that's running 3.3 volts, a lot of times it's not a problem, because when it's expecting 5 volts, it's just saying, well, anything above 2.5 volts is on, and everything below 2.5 volts is off. Mm-hmm. So you can, we've seen this when we've worked with the routers. Mm-hmm. When we're doing a TTY serial to a router, it doesn't really matter whether your TTY adapter is running at 5 volts or 3.3 volts, because if it's sending 3.3 volts and set for 5 volts, well, it's still above and below that 2.5 volt threshold. But it actually turns out these WS2812B LEDs don't work like that. Their spec is that anything above 70% of the input voltage is on, is a 1, is high, and anything below 70% is a low, is off.
Interesting.
And so that when you feed it with 5 volts, that means it needs 3.6 volts to go on. So you can't drive it with 3.3 volts. You can get level shifters and all that kind of stuff to bring it up, which is some complex circuitry for what we're trying to do that's simple here. But there's actually a really interesting hack that gets you around it. You can see I've got this diode here. Mm-hmm. So a diode just only lets electricity go one direction, not the other direction. Mm-hmm. Well, another thing a diode does, that not intentionally, but it happens to do, is it drops your voltage. And so this 1N4002 diode will drop 5 volts down to, I think it's 4.3 volts. Well, these WS2812B LEDs, they're spec'd, they need an input voltage of, I think it's 3.7 volts to 5 volts. So they're fine with the 4.3 volt input voltage. So all we're doing is actually just sending the 5 volts out from the board through this diode to drop the input voltage going on the voltage in pin on the LEDs down to 4.3 volts, which then makes 3.3 volts well above the 70%, and it works great. So that was a pretty slick little thing. We just have to add one of these diodes to the board.
Okay.
So that was the kind of testing I had to do. I wonder if I still got this one set up to show. No, I don't think I've got it still set up because it's not doing it. I must have I probably wrote the other code to this. So we'll not see the blinkies blink today, but that's okay. The other thing that I had to do was this STM32 board has 2 serial out pins.
Oh, okay.
So you can't just use any pin to drive the data signal for the AWS2812B. You need one of the pins that actually has hardware built in for all the clocking and stuff to do that kind of data. It's actually the MISO pin. Oh, I don't know what that means, but I know we have to use the MISO pin on Arduino quite a bit.
Yeah.
So it's got like MISO 1 and MISO 2. Well, the library that's available for this board under the STM the Arduino version of coding these, used the first serial port out, which has its pin, I think it's pin A5 or A6, right here in the middle of the board. I really didn't want people to have to solder all, 36 or whatever it is, pins on the sides of this.
It'll take a while.
These are people just learning to solder. It takes a while to do a dozen pins. I just wanted to put pins in the corners. The second serial port actually is just 4 pins from the end. So I had to kind of modify the library to use the second serial port. Wasn't hard. You had to tell it to use that port by changing some variables, but I actually had to figure out what speed it was running at and cut that in half because the 2 different ports have a different speed and you have to use dividers. So a lot of little futzing around, but ultimately that proof of concept worked. Take my word for it, the LEDs light up.
I believe you.
Yeah. So yeah, I was pretty excited that part works. So we're going to put a couple switches on there and make some kind of puzzle game that works with the switches and the LEDs. I like those little mouse switches. They're very fidgety, fun.
The ones we used on the Morse code.
On the Morse code, yeah. It looks like a little lever that goes up and down.
Yeah. Nice.
So that was the circuit and the parts. I guess the other thing I want to show you, because the other kind of hurdle was getting the STM32 working under Arduino.
Yeah, we're going to do that.
So yeah, if we pull open the Arduino IDE.
So let's jump over here. So this is basically a fresh install of Arduino on this computer. Alright, I was goofing around apparently and doing something. What do we want to do?
So, like most any other kind of just straight up Arduino board, we have to add the STM32 board to the to this. It's not going to come up in the boards manager by default, so we got to add a new board manager URL.
Okay.
And if you go to the go and Google STM-Arduino, you'll get the board manager URL. I gave it to you in a text file.
Okay. That's in here somewhere, right?
Yep. Right on that screen.
Additional board managers. There it is. Right in front of my face. Okay. Put that there. Okay. Now that's it, right? We just put the board manager in there, and then we can come in here and click board manager.
Put board manager, and it should then...
Because it loads it dynamically. Yeah, it's loading them now. All right, so what do I want to look for?
Yeah, STM.
That's it?
I think that's that one right there.
Click there, click install.
Hopefully that won't take too long. No, that's coming up. I did this a month or 2 ago on my Windows machine, and it worked just fine. I did it last weekend on my Linux machine at home with the latest version of Arduino, and the menus under the boards changed a little bit, so they updated it since I put it on the Windows machine.
Okay.
And on the Linux machine, after I did this step, I had to go and install some software from STM itself.
Okay.
I don't know if it's because it was Linux or because they had updated things, so we'll kind of see that here in a minute too. That was a really tough thing to figure out because it was like buried down in comments where someone's like, I'm having this problem, and the next person was like, oh, you need to go download the software from STM, and then the next comment after that was like, someone should put that in the documentation because this one blog post is the only place I've read that instruction.
So now we have that installed. We'll just go ahead and click close. And now what?
All right, so now let's do tools.
Board.
Yeah, we want to go choose the board.
Oops, board.
And this is an STM32F103, so STM32F1 series.
F1, got
Yeah.
it. All right.
There's lots of menus, so go back to that menu. Like, there's going to be more and more options. Okay.
Oh, wow.
Yep. So it's figured out the blue pill, so that's awesome.
Neat. 32K, that's correct.
I would actually just grab the one right below it, the generic
one. Okay.
Yeah, 32 is. I think it's either 64 or 128. I think the one without anything is probably the 64, which is the safe one to choose.
Gotcha. Generic serial.
We want that.
Yep. What's this? USB support.
You want to turn on USB support. This is what lets you do like serial
UART.
Yep. USB UART. That's fine. Optimize is fine. C runtime library is fine. And then the programmer. Okay, so yeah, this was the new menu. So we're using an ST-Link, which happens to be the same as STM32 Qt Programmer SWD. So the top menu option there.
So what's selected? Okay.
Yep.
So that's,
now on Linux,
this.
that's what I had to go pull down a driver for it.
Gotcha.
We'll have to see if that's the case here on Windows.
Okay. Oh, we haven't plugged it in yet, have we?
Yeah, we can go ahead and plug it in now. Take this off.
Yes.
Oh, you've got a USB extension. Nice.
Let's see if it'll reach. Okay. Here we go.
And it's
setting up device. Windows did a thing. All on its own.
And you don't need to choose a port because it's just a USB device. It's not actually a COM port that it's using there. All right.
Cool.
Let's just write a hello world type thing. So go to File, Examples, Basics, and then Analog Read Serial. So this is the most basic Arduino program. It reads the analog pin and prints it to. All right. Okay. So A0 doesn't make sense for this board, so just switch that to 0.
Just 0.
Just 0.
Whoops. I think that's what I wanted to do. Gotta remember I have 2 mouses now.
2 mouses?
Well, because this is a mouse.
I think I'm pushing you off the screen, too.
You are. Yeah. He likes to crowd in on my space. He's like that. He's a glory hog. All right. Good?
Yep. So, yeah, let's compile and
of course, I have it.
All right, so we got an error. What's our error?
Error. Expected error occurred.
Okay.
CLI not found.
So yeah, it looks like we need to install that.
Is this something I can just Google and find, or is there a special place I need to go get that, or?
Probably Google and find. I think I had to. You get it from the actual STM website.
st.com.
Yep. Oh, that's the.
Nope, that's the manual. That's not going to work. Yeah, if I would have read, it says PDF in the corner. Options.
I think it's the next one down.
This one? This one?
Yeah.
Programmer. Makes sense. We accept, yes, of course we accept cookies. We love cookies. I notice everybody's doing that now. I know it's a European thing, but all the websites.
Okay, I think you want Get Software at the top of the screen. And, oh. Yeah, probably.
Oh, yeah, I read that. Oh.
And then, yeah, you have to give them your name and email address to...
Okay, so now after downloading, so you do have to register on the website to download the STM driver that you need. You can download it. So basically, you put in your email address. It sends you a link. You click on the link. You download it. You click next a whole bunch of times, like any other piece of Windows software. Default install is fine, seemed like. And then we do the click upload to, we've got the Blue Pill plugged in. So go ahead and click upload. Does the compiling, of course, and should send it over. Do we change the COM port again?
It won't matter. It's using the ST link right now. Yeah. So the Blue Pill board has like programming headers on one end that connect to the ST link. There's other ways to program it as well. You can program it with a serial adapter. You can put firmware on it that'll let you even program it through the USB port, I believe.
Nice. So there we go. That was done.
All right. So it says the application is running.
Oh yeah, can't find COM. We just learned about that.
Yep. So we're unplugging this ST link.
Oh yeah, you can't see what I'm doing. Sorry, the cord's not long enough, but believe me, I'm unplugging the
ST
adapter
link and plugging in just the USB port on the other end.
Adapter there.
And so it just emulates a COM port. It's pretty nice too because it seems to emulate a COM port that Windows just sees without a driver. Here it's COM8, and we can see on the serial monitor we're just doing analog read serials, so it's just outputting whatever it reads on the pins to the screen.
Nice.
So proof of concept, you can program these on your computer now.
Nice, awesome. So yeah, that was obviously the big thing. We can put the notes in the description of the video as well of what links the sites that we went to. But yeah, so that's pretty easy. Okay, now what's next?
Well, do you want to come back in a frame and then show us fritzing?
No.
I can show you the board design we've gotten to so far.
All right, so we don't need this anymore. Bring up badge, Wumpusy Wumpus.
So yeah, we use fritzing a lot. Seems to be pretty easy to use for most things we do. And this is clearly something I designed because the schematic or the breadboard is not done at all.
The breadboard looks like this. The schematic is, I don't know,
a big mess. And here's,
so yeah, no, that's actually probably a worthwhile video at some point. I'm sure there's other videos out there related to fritzing, but it has a lot of features, and we only really use a couple of them. I probably use more of the breadboard stuff than you do, but yeah, PCBs. This is where we design all of our PCBs, pretty much for everything we do. So this is from above, so this would be the front, right?
Yep.
So
the black is the text or the silk screen that's going to be on the front.
There's the logo.
And the yellow is all the copper that's going to be on the front.
So then we've got a strip of 3 LEDs that will go right there. Awesome. Like we talked about earlier, we've got pins on the corners. So that's the Blue Pill will actually set it on the back, I assume.
No, it sits on the front.
It'll be on the front?
Yeah, because
the
dude's on the back. The Wumpus is on the back.
Gotcha. So the Blue Pill's on the front. This is your
diode.
Thank you. I was going to say capacitor, but I know that wasn't right.
And then two switches.
Two switches. So here's a dumb question.
Mm-hmm.
Where's the battery?
There's no battery.
Oh.
You powered off the USB on the...
Thought we just talked about putting a battery on it.
We could.
Was I not here for that conversation? Did I make that up?
I talked about how we like to have batteries on things.
It's true. And then I thought that was sort of a segue of we were going to have a battery. Because we enjoy having batteries on things. Now, disregard.
No, that's a good thought, though. You know,
I mean, if it's only 3.3, then we can get away with like a coin cell.
It needs 5 volts.
Oh, okay.
To drive the whole thing.
Oh, that's right. The LEDs can't power off.
Yeah, it's a constant problem we have. We love these WS2812B NeoPixel LEDs.
Yeah.
But you can't drive them with a single coin cell. And you could stack 2 coin cells to get the voltage you need, but I think it wouldn't last very long at all.
Yeah, that's fair.
Be
a fun test, though.
What we could do is make it taller and make place kind of for an optional 3 AAA battery pack glued to the bottom with a battery adapter. That wouldn't be hard.
It won't be hard.
All right.
I just like the idea.
Beta. Yeah, I think that's... I am sold. That's a good idea.
So yeah, as Kevin was just saying, this definitely in beta format. We're just still figuring this out. So here's the front side. Obviously, our company, the company we work for on a daily basis, Sickage, is sponsoring us at the Hardware Village, which is how we are able to give these things away for free. So big thanks to Sickage for giving us monies. Backside, of course, we have the big scary Wumpus. And again, the CypherCon logo.
Yeah, so if people don't want to sit around and solder, they can at least take a board with them, and it's just a bare board. It's a nice little souvenir with the con and whatever on it.
So are we thinking, like in years past, we've done black boards with white silkscreen? Or what are you thinking? What color should the Wumpus be, I guess?
So, well, PCBWay, where we usually get our boards from, is closed for the next 3 weeks because it's Chinese New Year.
Bummer.
But there's this other site I found, JCL PCB, who aren't closing over Chinese New Year.
Okay.
So I ordered from them. And one of the features is you upload your Gerbers, and then you choose like what color board you want, and they actually show you your design on the board.
Oh, cool.
White with black works really slick with these boards, like a black Wumpus.
Oh, so a white board?
White board, black Wumpus. And I actually ordered.
Nice.
Already ordered white LED strips. So I already made the decision without consulting with you.
We're gonna go with white. Nice.
I was just trying to get stuff done yesterday. So, like, I can start ordering stuff.
No, really, it's mine and Michael's project. It's all good. No, it looks great. Looks cool. Yeah. I'm excited to see them come in.
But I think
if we make them a little bigger. Yeah, because like we were talking about this before, but if we do actual size, I know this is very hard to get to scale, but that's what did we say? A couple inches?
Yeah, it's I think 6 centimeters wide by 7 centimeters tall.
Yeah, it's pretty little.
So, it's my nature to build these things no bigger than they need to be, because usually I'm paying for them out of pocket, which means smaller boards are cheaper.
Right.
But maybe I should have gone a little bigger here.
Yeah.
So I guess
maybe
this will let us check the circuit out, and we can add the battery, and maybe it actually gets kind of logged like a price tag looking thing, but that's okay.
From a circuit standpoint, there's really not too much to look at here, which is great.
Yeah. I really wanted to keep the number of solder points really low.
Yeah.
We had, about 250 people solder.
Gosh,
the version 3 board together at CypherCon. So
the arcade
game,
yeah, and that was a fun project. But yeah, there was a lot of soldering. I think that's why we didn't get a lot of throughput as far as people go.
Yeah.
So yeah, with a smaller board, simple soldering points, we can get more people to go through the village and enjoy it.
Yeah.
Sweet. I'm excited.
Yeah.
So then I guess next time we get together, a couple weeks.
Yeah.
Hopefully we'll have it this week.
The package should come in a week or two. So I think next video we unbox and put a couple together, and you can watch us troubleshoot something that comes in the mail and see if it actually does what it's supposed to.
Right. Imagine that. Cool. Well, thank you for sharing this, Kevin. That's awesome. And appreciate you setting up my computer for me.
Okay. We'll see you all soon with the next board.
Till next time. See you later.